So two of the areas that I'm really interested in are computer graphics and human-computer interaction. And so what I thought I'd do today is tell you about a set of projects that combine ideas from both of these areas. And in particular, I'm going to focus on some of the tools that I and my collaborators have developed to make it easier to manipulate visual imagery. Before I begin, I just want to mention that this work indeed was done with a number of collaborators. And in fact, throughout this talk, whenever I say that I've done something, you should really be thinking it's these people who did the work, particularly the ones in blue. They are the students that were involved and did the hard work that I will be telling you about. Okay, so let's start by thinking about visual imagery, and in particular, digital imagery, digital capture. Digital cameras really started to become popular about 15 to 20 years ago or so. And over the last 15 years, they've very significantly changed the way we capture the world around us. So today, it's really, really cheap and easy to go out and take a picture of the world, capture a snapshot that looks like this or like this. And we take these things sort of effortlessly. But the snapshots that we capture using these devices are rarely really compelling images. So here's a picture of my friend Alex and his wife. And it's a nice picture, but it has some things that I think are not that great about it. In particular, his hair is in his face. Alex's eyes are somewhat closed. There's this person in the background that's somewhat distracting. And and you can imagine that there would be a better version of this picture with some of those elements replaced and edited. So of course, what can we do today? We can go and take a picture like this, move it into a tool like GIMP or Photoshop, and very carefully edit the image and make the image better, correct the flaws that we see in the photograph. But that's a lot of work. It's a lot of work to learn these tools. It's a lot of work to use these tools. You're essentially working down at the level of pixels. And so what I'm really interested in is developing interactive design tools that allow users to express high-level design intentions. So I just want to be able to say, fix the hair, or remove this person in the background with a single click, and give a high-level intention. And then I want the computer to handle the low-level details of fixing the hair and removing the person in the background. Or I just want to be able to say, fix the image, make the image better, and have the system do a set of default actions to make the image look better. And so what I thought I'd tell you about today are some projects that are designed to do some of this. I'll focus on 3 projects. The first one is on digital photo montage. And the idea here is to combine the best parts of multiple images into a seamless composite. Then I'll tell you about some work on automatically generating tutorials and macros for tools like Photoshop and GIMP. And then finally, I'll tell you about a tool that's designed to make it really easy to create animated content in the style of paper cutouts. So let's start with the first project. This is the photo montage project. And to motivate this, imagine that you're taking a picture of your family at a family gathering or a holiday. Now, invariably, what happens is that you take a picture and one person looks great. He's smiling, looking at the camera. But another person is maybe looking off camera, not really smiling. And so it's not the best image. Well, with a digital camera, what we do today is take another photograph. But again, we had the same problem. So we take another photograph, and another one, and each time we run into the same problem. It's really difficult to find a photograph in which everyone is smiling and looking at the camera. And so we thought, well, wouldn't it be better if you could just take that set of photographs and then piece together the best parts of each photograph to form a composite image in which everyone is smiling and looking at the camera. Now this, of course, doesn't represent any true instant in time, but it's a seamless composite that maybe better captures the family the way you wanted them to. And I should also point out that you could, of course, go into Photoshop and very carefully cut together the best parts of each photograph, but that's really a lot of painstakingly tedious work. Right? So what I really want to do is have an interface that looks something like this. We have a set of source images, and I want to just coarsely mark out the best parts of each source for the final composite. So I'm not carefully cutting between them. I'm just saying these are the faces. These faces here marked in yellow are best in the yellow image, and so on for the other strokes. And then the system is going to choose where to cut between the images in order to produce this seamless composite. So it's going to do the tedious low-level work. And when we do that, we get this seamless composite that I showed you earlier. So that's the interface that I'd like to set up. And the way we do it in the photo montage project is we set up an optimization procedure. We use graph cut or min cut in order to choose where these seams should go. And the paper goes into a lot more detail about how this optimization is set up. I won't go into the details here, but what I will try to do is show you a demo of this. So let's hope that this works. Okay, so this is Mira, and I took this photograph of her, and she has this really nice smile, but unfortunately her eyes were closed. But luckily I have this other picture of her, and her eyes are open, but she's not smiling. So what I want to do is transfer her eyes, her open eyes, to this image where she has the nice smile. And I could very carefully cut out the eye and paste it in the other image, but what I'm going to do is just draw this kind of rough stroke. I'm not covering the entire eye, and I'm just very coarsely drawing it out, and the system is doing all the work of pasting the eye in the other image. Let's see if I can do that here as well. Oh, is that going to work? Okay. So VMware is having some problems here. But the main point here is that I don't have to be very careful in drawing out those strokes. I can kind of draw them roughly over where the eye is, and it'll transfer the eyes. Here's another image. This is Asim. Both Asim and Mira are authors on this paper, so they're going to be OK with what I'm going to do here. All right. So again, really fast and easy to create these kinds of composite images. All right. Let's kill this.
Yeah.
Okay, great. So it. Sorry about that. Oh, that's not good. we'll show you that later. Let's see if PowerPoint will come back. Anyone still need coffee? All right, let's see if this works. Okay, so the main point there was that it's really easy. This interface makes it really easy to composite these images. Now, it turns out the same idea can be used in a number of other places. So here, I snapped off a set of pictures of this sculpture, and now I want to use them to relight. I don't like the shadow on the back, so I'm going to choose the color of the back wall, draw a very coarse stroke. The system is going to find the best image to fill in that shadow, and then paste it in. And it didn't quite get rid of all of the shadow, so I'm going to draw another stroke and get rid of the rest of the shadow. I don't like this highlight at the bottom, so we're going to paint that out. And we're going to move some of the other highlights and shadows around this sculpture. And so as a post-process, I can take this set of input images. I took those images by just waving a flashlight around, snapping off a set of photographs from a fixed location. I didn't need to know where the flashlight was. All I need is a small set of images. And then after the fact, using the system and these really easy strokes, I can relight the photograph and move the highlights and shadows around. Here is the resulting composite image. And it looks reasonably realistic, but I'm really compositing lighting from different images in a non-realistic way. We can do other kinds of relighting as well. So here's a data set from Paul Debevic's light stage, just moving a light source around this person's head. And then we can use the system to relight that image in different styles. Okay, here's yet another example. So in entomology, scientists are taking photographs of very small insects. They don't get good depth of field with the macro lenses that they are using. So only a small part of it is in focus at any one time. So here with this ant, just the front tip of its proboscis is in focus, and we can move that focus plane back through the head of the ant. So here I've moved it back a little more, back a little more, and just sweep it through. So I get just a kind of a plane in focus in any one of these images. I can throw this stack of images into our system and then run this max contrast objective in our graph cut optimization. What I get out the end is a photograph in which the entire head of the ant is in focus. So there's another application. Here's yet another one. So when we are taking panoramic images, a lot of cameras support this today. You can just wave a camera around a scene, snap off a bunch of images, and then it will stitch them together into these panoramas. When we do that, if anything is moving in the scene, it shows up as ghosts. So here we have a bunch of ghosts of the people. But if we use this most common color objective, we can get rid of all of those ghosts automatically using this photo montage technique. And similarly, we can create these kinds of clean plates. I'm at a tourist attraction like the entrance to this cathedral. I don't want all these tourists in the image that I don't know, so I snap off a bunch of photographs again, choose the most common color. I almost get rid of all of the tourists in the automatic results, but there are a few here, and that's because there were kind of dark pieces in this part of the image in all of my inputs. So I draw another kind of eraser stroke, and it chooses another image to composite into that location. And then I get this clean plate back. So these are the kinds of very simple interfaces that allow me to quickly express my design intentions and then generate the desired result. And that's really the main takeaway from this project. These high-level, these coarse strokes can provide high-level controls. And we can also have a good set of defaults, but allow the user to modify the automatic result to produce an even better result. Now there is some future work, I think, in this direction. And one of the things that I'm particularly interested in is how much constraint information can these coarse strokes provide. So photo montage is just one of many systems that's been designed to exploit what's called by the graphics communities, what are called scribbles. These are very coarse strokes that give a little bit of a constraint to these systems. And I'd just like to better understand what kinds of information we can get out of scribbles. And then the other thing is, how easy is it for people to specify constraints through these kinds of scribbles? I think that's also really worth studying. OK, so that was just one example. What I want to switch to next is some other work that is also kind of aimed at helping people create better images using tools like Photoshop. And this is work that, on one side, is designed to help people learn to use these tools through the creation of tutorials. And on the other side, is designed to help people automate the process of doing manipulations on their photos through macros. So let's start with tutorials. So today, when people take photographs, there are many kinds of modifications they might want to make. Skin tone correction is shown here. We might want to add digital lipstick. We might want to enhance the sky, convert from day to night, a bit more exotic, add snow to the images, and so on. And all of this is possible through tools like Photoshop. In fact, there are tutorials on the web and in books that will describe how to achieve each one of the effects that I just showed you. But of course, as I mentioned before, these tools are really complicated and difficult to learn. And so people really have to use the tutorials in combination with these interfaces. When people are first learning to use Photoshop, they don't use the manual. They look for a tutorial that's similar to the task they want to do, and then follow that tutorial and adapt it to their content. So here are the kinds of tutorials that you find. This is from a book that I've shown here. It's describing how to remove red eye. And what you'll notice about this tutorial is that there is text along with screenshots showing you exactly what you have to do step by step. So what makes these tutorials so effective? Well, we can analyze them a bit, and we see that it helps that they are really step by step. They show one major operation in every panel. They tend to be fairly succinct. So in practice, when we are manipulating images, we might perform the same operation several times, trying out different possibilities. But in the tutorial version, you just show the best form of the operation. And the nice thing about printed tutorials like this one is that you can get an overview of the entire sequence of steps. And you can also kind of look at each panel individually to better understand each step on its own. And then, as I mentioned before, there's screenshots and text that really describe how to perform each one of the steps. Of course, the issue here is that creating really effective tutorials is a lot of work for a designer. And so, so what's been happening today on the web is a lot of people have started creating video tutorials. And these are just screen captures of a person using a system to perform a particular manipulation. So in this case, I think removing red eye. And the advantage here is that it's really easy to create one of these video tutorials. You simply use some screen capture recording software, and if you're really going to try and create a high quality one, sometimes you'll put in a voiceover describing what you're doing. But these screen captures are usually very long. They include mistakes and unnecessary steps. And the viewer has to work at the pace of the recording, right? They can't go from step to step at their own pace. And so the goal of this work is to start with a demonstration and automatically generate a kind of high quality printable tutorial. All right, how are we going to do this? This is the basic overview of the system. So we're going to start over here on the left by doing the same kind of screen capture recording as an expert user is performing a manipulation. And we've instrumented the software that they're using in order to also capture the set of commands they are performing. So that's essentially the same as before. We are also going to rely on a little bit of computer vision technology to label the image that the user is working on. And specifically what we're going to do here is rely on labeling faces and labeling landscapes, because those are two very common forms of images that are manipulated today. And using this information, we're going to create these kinds of printed tutorials. So let's talk a little bit about the recording procedure. As I mentioned before, we've instrumented the software to capture the interface state, the state of the buttons and sliders and so on, and also the state of the application. So the set of operations that are being performed in the operation and their parameters. And at the same time, we're also taking screenshots of the screen so that we can have these visual images for our tutorials. And there's a whole cleanup procedure on this recording. I won't go into the details there. But once we have this information, the next step is to take our screenshots and annotate them, highlight the interface elements that the user has to work with as they're trying to perform each step. So here we highlight elements in the toolbar, highlight the navigation to menu items, and so on. And finally, we want to create text annotations. And here we use a template-based approach. These are the templates that I'm showing you here. And for each kind of operation, we have these green variables that describe something from the interface or application state, and we have these blue variables that are based on labels from computer vision. So here we might say paint using the paintbrush tool on the eye of the person. Okay? That's the kind of result that we get using this approach. And as I mentioned before, the labeling comes from computer vision. We use a face detector as well as a sky, ground plane, vertical plane detector shown here. Okay, so we have all of that information. The final step is to lay out each step in the form of a tutorial. We use a basic grid-based layout approach where we have each major step along with a screenshot showing you how to perform the step. And then at the very beginning, we show the before and after, so you get a kind of overview of what this tutorial will allow you to do. Okay, so that's that's the entire system. Here are the kinds of results that we can produce. I've shown you thumbnails of 9 of them. It takes about 5 to 10 minutes to demonstrate each of these workflows. And then tutorial generation goes very, very fast once you've done the demonstration, just a couple of seconds. And to give you a better sense, here is one of the results. This is night to day. So we demonstrated on this image, and here is the kind of result that we've gotten. It's a little bit hard to see the text, so I'm just going to zoom in a bit here. And what I want to point out is here, the stuff in bold, this is all of the information that we filled into the template. So instead of saying select the region, then click on, and so on, we say select the sky using this particular path tool, well, the creation selection tool from the path tool. So all of this information is kind of coming out of our recording and then put back together, synthesized into these tutorials. Okay, and then you can see the kind of highlighting we're doing to help the user understand the interface elements that they have to interact with. And this tutorial runs for 3 pages and takes about 17 steps. Okay, so that was our system, and we have studied the system a bit. We ran a user study in which we compared our automatically generated tutorials to a tutorial from a book, but we replaced the images from the book tutorial with our images to control a little bit for that difference. And we also compared that to a video screen capture with a recorded voiceover. And we chose 3 different kinds of tutorials, and we gave them to people in a fixed ordering, from simplest, the eye recoloring only had a few steps, to the night from day, which had 17 steps, as I showed you before. And here are the results. We had 18 subjects, and with our tutorials, the subjects were both faster and made fewer errors than in either the video or the book case. Okay? So this is a kind of indication that our tutorials are usable. What's interesting to me is that that our tutorials were better than the book. We expected that they might be better than the video tutorials because people can proceed at their own pace, they get this overview in detail, and so on. The fact that it's better than the book is interesting, and I think what's going on here is that the book provides a lot of explanation for why a person should perform each step, but they often condense the information and leave out important steps. And so that may be the main reason that we're beating the books. And I think more study can be done here. The other thing, we looked carefully at the user feedback, and really the text descriptions and the locations of the tools really helped people understand where they should do, what kinds of actions they needed to perform. Okay, there's again a bunch of future work to do here. So we'd like to do more user studies. We'd like to better understand how much screenshots really matter for learning how to do these tasks. We'd like to see if people can generalize from a tutorial about red eye correction to changing the color of a shirt in another image. There are a lot of similarities between correcting red eye and changing the color of an object or a shirt, and how well can people generalize this And what's interesting here is that books provide a lot of explanation. They describe what each operation is meant to do. Our tutorials don't give any of this explanation. They just describe what to do. They don't describe why it's being done. And so we'd really like to understand how much explanations can help. Of course, we might apply this approach to other domains, assembly instructions, recipes, we can think of many others. And then finally, we're kind of interested in this idea of interactive tutorials, tutorials that might adapt to what the user is doing and help the user perform the individual steps. And this is really related to the idea of having macros. And that really leads to the next part of the talk. So let's think a little bit about macros. So today in Photoshop and in GIMP, you can record a sequence of operations as you perform them and turn them into a one-button press macro. The macro will just perform that same set of operations with the same parameters on another image. So the macros encapsulate operations and operation sequence with their parameters. The problem with these current macros is they can't really adapt to the underlying content. So here I've given a new target image, and we see this result. And there are two kinds of problems with applying a macro that was generated for this image on this image. One problem is that the spatial locations of the operations may have shifted. So the skin is not really in the same location in these two images. Okay? And the second problem is that the parameters that we use to adjust the skin color here may not be the same parameters that we want to use for this image here. And so we get this really bad looking result. So what we want to be able to do is take a set of demonstrations and then learn how to map the spatial locations and these parameters to a new image. So that's the overall goal. Now, when we started this project, we kind of looked at a whole bunch of websites that contain tutorials and also macros to do various kinds of operations. And one of the things that we found was that there's, of the total set of tutorials and macros that we looked at, 151, about 30% are designed to operate on the entire image. So we call these global manipulations. They don't rely on any kind of spatial correspondence. Here we're modifying the color of the entire image. Another 26% are all about manipulating faces in some way. So here we're removing the bags under the eyes, but there are a lot of manipulations that are designed to affect faces. And that makes sense because people are interested in faces and pictures of faces. And then another 18% are aimed at manipulating landscapes and improving the look of landscapes, like sunsets and skies and so on. And finally, there are 26% that are aimed at other kinds of specific objects in images, cars or parts of the body and so on. And our work is really going to focus on these first three classes of manipulations. We're going to handle global manipulations, faces, and landscapes, and I'll describe why we focus. Well, we focus on these three because they cover a large percentage of the tutorials and macros we found online, but we also focus on these three because we're going to rely on computer vision, and we have good computer vision techniques for identifying faces and landscapes. Okay, here's the overall approach. Again, we're going to record demonstrations of the macro. We're going to then learn the spatial parameters as well as the other operational parameters, and then apply to new images. And as I just mentioned, a key piece of this is computer vision image labelers that will allow us to build spatial correspondences. So if we have an input image that looks like this, we can use our face labeler to extract the different parts of the face, the nose, the lips, and so on. And similarly, we can apply that on a target image, and that helps us form these spatial correspondences. Okay, so with that, let me just show you an overview of how the system works. This is the interface, and here we're going to show a lip gloss manipulation, and there's sound with this video. So,
create a macro for adding lip gloss. The user first demonstrates the manipulation on a portrait. The label and correction panel shows a list of facial features our image recognizer identified. As the user selects a region in Photoshop, our system recognizes it as the upper and lower lips, and automatically checks these labels in the list. The panel provides feedback showing that the system properly interprets the selection. Next, he adjusts the hue saturation and the color histogram of the lips. The last step is to paint a highlight on the lips. After the user performs the first demonstration, our system creates a macro application panel that shows how the image appears after each step of the manipulation. When the user encounters a new portrait that he wants to apply lip gloss to, he selects the lip gloss macro from the list of all recorded macros, as shown here. The panel now shows the result of automatically applying the macro to the new target image. After only one demonstration, the results will likely require some corrections. For this image, we immediately see that the first step of the adapted macro is incorrect. The lips are in the wrong position. The user clicks on step 1 and corrects the selection. Then, he switches to the label and correction panel and checks the upper and lower lips to associate these labels with the corrected selection region. He switches back to the macro application panel to apply the changes. The adaptation looks pretty good, but perhaps the effect is a bit too strong, so the user clicks on step 4 and adjusts the color curve parameters to decrease the redness of the lips. Applying the changes propagates them through the rest of the macro. Our framework treats each corrected macro result as an additional training demonstration to improve the quality and robustness of the macro. After 4 demonstrations, the system runs a leave one out cross-validation to estimate the macro's robustness. For every new target image, the panel displays the average error for each step to indicate the system's confidence. High values are shown in red so that the user can quickly check whether these steps need to be corrected. As the user adds more training demonstrations, the macro becomes more robust, and the error values decrease. Our experiments indicate that our macros produce consistently good automatic results after about 20 demonstrations. Our macros can also be applied automatically in a batch mode, rather than using the panel.
Okay, so that's an example of how the system creates these macros, and it's a very interactive thing. You demonstrate a macro, bring in a new image, demonstrate again, but you're using the learned results from the previous demonstration to help you along the way. And eventually, we can generate these fully automatic macros and apply them to new images. A bit more detail about how this works. Our system really considers 3 kinds of operations. Image processing operations, like changing the hue, saturation, blur, etc., filtering, essentially. There are also selection operations that select some region of the image. And there are brush strokes. And these, again, are sort of selecting a region along a particular stroke path. And so there's kind of 2 main classes here. Global operations that affect all of the selected pixels. And then spatially local operations. Selections act on a localized region of space, as do brush strokes. And so we need to learn how to transfer or adapt all 3 kinds of operations. So let's start with adapting the parameters of these global operations. Here, what we want to do is take the current selection, compute some features on the current selection, and then build a mapping from that set of features to these output parameters for brightness and contrast. And our approach is to assume a linear model like this one. And the key problem here now is to estimate these coefficients from the features and the demonstration examples. And so we could use a number of techniques. Least squares would probably be the simplest approach. We found that in practice, this least angle regression produces better results. It produces sparser results. It forces many of the coefficients to be 0. And so it only uses the set of features that it really needs to use to learn this mapping. And then what are the features? Here we're using some pixel level features like colors, various statistics about the colors, and then label-based features from our face detectors that give us the width and height of each of the labeled regions. So that's how we do the parameter learning. The other thing we have to do is learn the selections, how to adapt the selections. So here, what we do is for each pixel in the selected region, we form a feature vector. For each pixel in the non-selected region, we form another feature vector. And then in order to classify a pixel in a new image, we apply naive Bayes, very basic, simple machine learning technique to determine whether a pixel is selected or not selected. And finally, we need to adapt brush strokes. So this really begins in the same way as we adapt selections. We first figure out the brush region using naive Bayes. And then to transfer stroke paths, we assume this kind of Markov chain model. And the key idea here is that the position of the next point on the brush stroke depends only on the state of the current point. And to show you in a bit more detail, suppose the current point on the brush stroke is P. We consider a small neighborhood of points around P, and we're going to then choose the next point to lie on the stroke as the one that maximizes a transition probability that's based on the features that I showed you earlier. Okay, so that's just kind of a high overview. Again, a lot more details in the paper. I want to jump to results here. So this basic approach, we've tried it on about 20 different manipulations. And from all 3 categories, global, landscapes, and faces. And what I'll do here is just show you the results in all 3 categories. So here is global manipulations, and this is a Lomo effect, kind of increasing contrast. And so here are our results. We can create these kinds of reflections. So here's a demonstration, and then new target images, and automatically generate these kinds of reflections. This is an interesting type of graphic effect. And again, we can learn how to transfer that to new images. We can also do things on landscapes. So here's one on waterfalls where we smooth the waterfalls and produce a kind of blurring effect, enhance sunsets. And then finally, dark sky here. So really change the look of these images fairly significantly. And then we can do some face-specific stuff. So here is a kind of contrast adjustment where we're really adjusting the contrast mostly inside the face. And we can add makeup to the eyes. So, and then let's see, this film noir effect, again, kind of changing the black and white contrast within the face separately from the rest of the image. This is a bit subtle, so it's hard to see. And then finally, this mustache example, adding mustaches to faces. And here are some positive examples where the system worked fairly well. Just to show you, one thing that the system can't do is learn these long-range dependencies. So here the hair should obviously be red. It's black instead. And we haven't kind of learned the hair color. So that's something that our system doesn't yet do. OK, we evaluated this system. So we took 7 of our manipulations and 50 to 100 images in each one. We created, we kind of generated 4 kinds of images. There's a ground truth image. This was an image that we manually manipulated. We created an average image, and this just averaged the parameters and copied the selections and brushstrokes directly. This is kind of a straw man baseline approach. Then we used our content adaptive macros, and this is with the automatic computer vision labeling. And then we also did one where we corrected the labeling wherever it was necessary. And the reason we created this corrected, the reason we tested this corrected method was to test how much of the error was really due to the computer vision, the labeling, not part of our system. We can use any labeling method, and how much of the error is within the learning that we do. We put these on Mechanical Turk, so we put up a set of 4 images, one of each of those categories, and asked people to rate. So we always put the ground truth in this position, and asked people to rate how close each of these other images was to the ground truth. Okay? And numbers closer to 1 indicate less difference. All right, here are the results. And what you can see is that generally the ground truth were rated closest to ground truth. That's good. Our techniques in the middle here, blue and orange, were rated pretty good. And then the average technique, our straw man, was rated much worse. And so what these results indicate is that the macros, A, are better than the average results. They're in fact closer to the ground truth than the average. Corrected results are only slightly better than the fully automatic results, and so we were pretty happy about that. And then the macro results are often indistinguishable from ground truth, and what this means is that in 47% of the cases, in 47% of the automatic cases, users were confused. They rated the automatic result as closer to ground truth than the ground truth itself. Okay? So one of their options for comparing to that image on the left was the ground truth itself. They often rated ours better. And so that was interesting. And then the other thing that we did was tested how many demonstrations it required in order to produce these results. So here, with one demonstration, we see that this ground truth line, most of the ratings are fairly close to 1, whereas our technique, as well as average, all have kind of consistently bad ratings. But as we increase the number of training examples, we see that by about 20 training examples, that our results are much closer to the ground truth in terms of the user ratings. Okay, so the takeaways here, adapting most photo macros requires learning the operation parameters, selections, and brush strokes. So we should really focus our efforts on creating learning techniques for these 3 kinds of operations. And finally, what we've done is we've produced a kind of framework that relies on automatic labeling from computer vision. And the framework is designed to be extensible so that you can add in new labelers as you get them. So we've recently extended this to work with car labelers. We found a labeler that would find a bounding box for a car. And here, it's a bit hard to see, we've adapted this kind of tilt shift effect for these images where it finds the car and kind of blurs the region around the cars. That works fairly well. Here we've taken a recoloring macro. We find a car and recolor it to be blue. It works as long as there isn't much red outside of the car. And so here, this grass has a little bit of red coloring to it, and that gets recolored here as well. So, the macro isn't perfect, but as we get better labelers, we could do better. Okay, future work here. We'd love to learn those indirect dependencies, like the hair color that I mentioned earlier. Another issue with this system is that it requires aligned demonstrations. The person has to perform the same sequence of operations in the same order 20 times. And that can be a bit difficult. So we'd like to get around that, and I think there are ways that we could correct small misalignments fairly easily. And then finally, one of the things that I'm really interested in is this tension between tutorials and macros. Tutorials are designed to teach people how to do various kinds of manipulations. Macros are designed to fully automate the manipulation. So a person doesn't learn from a macro, it's just applied. And I think an open and interesting question is when to provide instructions and when to fully automate. Right? And are there places in between where we can partially automate? What are those places? All right, what I want to do here is briefly conclude with one final project. This is on video puppetry, and this is a project that's aimed to make it easy to create a different kind of content, namely animated content. So again, just to remind you, you can use high-end software like Maya, shown here, or even Flash, other tools to create animated content, but learning these tools is really difficult. It takes a lot of work. And so we thought, well, what we'd really like to do is make it easy for anyone to create animated content. So here's the approach. A person draws on a piece of paper, cuts it out, and then moves these objects in front of a camera and produces a result like this. So in a little more detail, here's our artist. This can be anyone. Everyone knows how to draw. We've had children as young as 4 years old do this. Cut out the character on paper, put it under a camera. The camera takes a picture and then forms a map for the object. Okay? And then once we've matted out the objects, we can create these kinds of animations. So in this case, we've matted out several objects. We've in fact created an articulated character. I'll show you how to do that in a second. We can create these kinds of animations that really, really easily and quickly. Okay, so how does articulation work here? We just draw each of the pieces of the character, show each one to the camera, create those mats, and then we have a bit of a GUI in this case to show how the different parts should be connected to one another. So that's the basic idea. And then in order to really create these animations, the key technologies here are that we need to be able to track the motion of the puppets as the person is moving them under the camera. And so we rely on a combination of techniques. The first one is SIFT, which I know everyone here is familiar with. We're using SIFT to basically identify each one of these moving puppets in the camera view. Our implementation at the time we did this was not real time. So you can see there's a kind of lag in the updates. And we're combining that with a real-time KLT tracker. So this tracks where points move from frame to frame. And this is real time. Those points are sticking to those objects. But it doesn't identify which puppet is which. It doesn't identify that the moon is the moon and the sun is the sun. SIFT, on the other hand, does provide this identification. And so we can combine these together and okay, and you can take my word for it. These things track and identify properly, and then hopefully we have some examples. So here, once we've built the system the way I just showed, we can have one person running it in California, another person in Berkeley, and create these kind of shared animations. We can also separately animate different tracks. So here, one person starts by animating the body of the octopus, then animates the arms, and we put it all together into the final result, as shown here. We can also add these kinds of scene effects. So here we've attached this kind of flame puppet to this flame effect. And whenever we show the flame to the camera, the flame comes out. And similarly, we can attach this rain to the rain puppet using this kind of GUI. We can also have walk cycles. So here, the walk cycle is generated as another kind of special effect. We'll change the number of legs on our dog. And here's the GUI for creating that kind of walk effect. And then there are various state change puppets. I showed you how we can attach state changes, and here's the fire breathing from the dragon onto the night. And this was the animation that our 11-year-old user created from scratch. Okay, oops, okay, I see these are a bit out of order. So this is, once we've added a walk cycle, we can also create these kinds of 2.5D effects. We can add a kind of ground plane, and then as the character moves from the front to the back, its size changes as well. It scales up and down in size. And the way we add this is through yet another GUI. We set a horizon line, and then rescale the character at the horizon, and then linearly interpolate between these different sizes. Okay. Once we have a ground plane, we can also create these kinds of cast shadows, and we can add this sun puppet to indicate the direction of the shadows. We can have camera control, so we can put in different backgrounds by showing different images, and then these two hands can kind of frame the shot. And so you can see there are a number of different effects that we can achieve through this approach. So the main idea here, again, is an animation interface that just about anyone can use. We've tested it with people that are as young as 4 years old. It does require a bit more work to put in special effects or do these articulated characters, but the basic approach is really open to anyone. Now, there are some future directions here. One thing we'd like to do is take an articulated puppet and just demonstrate the articulation and learn the joint structure. We think this is possible. We'd like to create tools for editing performances. So often, people will perform the same kind of motion multiple times because they aren't quite happy with initial takes. And so we want to combine the best parts of each take, maybe using an approach like we did in photo montage. And then finally, we'd like to extend this to 3D to work with 3D puppets and 3D toys. And we're starting to do that with the Kinect. Okay, so just to finish up here, visual imagery, I think, is really essential for communication. And I've put a little bit of why I think this is so important. Facebook, 250 million photos a day are uploaded to Facebook. That is a lot of images. We are similarly sharing lots and lots of imagery through other online sites. And that's just what's shared, right? There's a lot of imagery that's created that's not shared. So this stuff is really important. But often the best imagery, the most effective imagery, is carefully manipulated. On the other hand, today's manipulation tools and creation tools are very difficult to use. And so what we really need here are simpler tools for manipulating visual imagery. And to that end, I just want to return to what I started with. We need tools, I believe, that allow users to focus on high-level design intentions and let the computer handle low-level details. Thank you very much for sticking this out. Happy to take questions. Yeah.
I know that you mentioned that the video, one of the drawbacks is that like it has unnecessary steps and mistakes.
Yeah.
How does your tutorial program fix that?
Yeah, great question. So I didn't go into the details here. We're capturing the set of operations that a person is performing. So we do certain kinds of cleanup. If the person is performing the same operation multiple times, we can just take the final version of the operation. Or we can sometimes combine multiple steps of the operation into a single operation. We can combine the set of parameters into a single parameter. So,
Ever make mistakes like where it thinks that's unnecessary, but it is necessary? How
Yeah.
do you deal with stuff like that?
So we have very simple rules for doing it. So those rules are designed not to, it's not possible for the rules we use to make mistakes in the sense that it can't simplify something that shouldn't be simplified. On the other hand, it might not simplify enough. So that's the kind of mistake it can. Yeah, good question.
Yeah, just back on the tutorials.
Yeah.
So you do better than the books.
Yeah.
But you didn't say whether you have more or less sort of data presented to the user. So were your tutorials longer than the book tutorials or shorter?
Yeah, I'd have to go back to the paper and check, but what I think happened is that the tutorials that we presented did have more information in the sense that they filled in some steps that the book assumed anyone who was following this tutorial could easily do. Books tend to skip over steps in an effort to make their tutorials even more succinct than our tutorials. And so it's a good question. These things are probably not informationally equivalent. On the other hand, the book provides explanations for their steps. That's something that we don't do, and that's something that we'd like to test as well going forward. So there are advantages to books. I don't want to say that they're not.
It seems like you might also be able to do some reduction just by essentially mimicking what the book does and sort of automatically reducing some of the steps, maybe referring back to another tutorial or something like that.
Yeah, that's a great point. And I think it gets to her point as well. The rules that we've used for simplifying tutorials are very, very simple, and perhaps more could be done. We just don't want to oversimplify. And so there's a kind of balancing act that needs to be performed.
For your example of removing the tourist,
Yeah.
so I'd like to, after coming back from a holiday,
Yeah.
just tell the computer, just get rid of all the tourists in my pictures.
Yes.
Have
Yeah.
people taken the application to that point?
I'm not aware of it if people have I believe there are various tourist remover applications available, but I don't know how they work. I haven't looked at them.
Because I just imagine that if you were collecting the data, the tasks that people would do in montage, one would think they tend to be the same. A lot of people will be putting happy faces, removing the tourists. So if you were collecting the feedback,
Yeah.
then hopefully you could then have these meta tasks.
Possibly, yeah. It may be a good way to proceed and extend this work for sure.
I just wanted to say the video puppetry was really cool, and I was wondering if it was available for people to use.
Yeah, so we haven't released it largely because the students that worked on it graduated. So that's always a tricky thing in this business. But yeah, I would love to see it released. So we are kind of starting to work on this, on the 3D version of this that will use the Kinects to track 3D objects, and that will also do all of the stuff that the 2D version does. So hopefully we can get that one out.
Just thinking about the tourist removal.
Yeah.
If instead of 10 images, I gave you 10 minutes of video,
Yeah,
which is
Yeah.
how many thousand frames?
Right.
Yeah. Does the optimization framework start to suffer or start with?
yeah. So graph cut may not be the best optimization procedure if you have that much video and data. In fact, if you have that much video and there's a lot of motion, a median filter might do the trick. So yeah, there are other approaches. This one I think is best tuned to having a very small set of images. Yeah.
Yeah, just wondering if you're still thinking of further follow-ons for the macro by demonstration, because in the extreme it becomes a kind of programming by demonstration.
Yes.
And stuff like
Yes.
that. And then if you have an ecosystem for sharing macros.
Right. Yeah.
And
Yeah.
so just wondering if you project
Right.
forward how you see this developing.
Yeah, so I'm very interested in the space of instructions. And there are a lot of websites today that give instructions, some domain specific, some not so domain specific. You may have heard of Instructables. They were just bought by Autodesk. So instructions is a big domain, and with respect to these kinds of photo tutorials and macros, it'd be great to have a site where you could share both of them. I think there are a lot of benefits to sharing tutorials, and there are a lot of benefits to sharing macros. And having other people annotate tutorials or macros, fix problems. There are debugging issues as you start to do more of this programming by demonstration. And I think there are a lot of benefits to this kind of sharing. So that's something I'd love to explore.
When you were talking about this tension between macros or tutorials, have you thought of like some sort of task that the user might be trying to accomplish, or successive series of tasks, and then try to formulate it as an active learning problem?
Yeah, so we haven't gone to that degree. We haven't done it as you've suggested. We're just starting to think about how one might address this tension. I think that's a very good suggestion, and would love to talk with you more about it. I don't know enough about these kinds of active learning techniques to really say how that would work in this setting.
All right, we should probably wrap up. Thank you,
Okay,
Maneesh,
thank
once
you.
more.